we're going to explore using playing cards, which will actually pop up in multiple examples, so you need to be familiar with what a deck of cards looks like. All right, so let's take a look at these examples. So you randomly choose a single card from a standard deck of cards. Find the probability of choosing a heart. So the probability of choosing a heart. Now, I will want you to be using this notation, so don't just give me the fraction. Use this notation and show me that you're going to find the probability, and then inside the parentheses, either write the verbal description of the event that you're trying to find the probability for, or if you want to tell me that you're going to call a heart, maybe you're just going to call that event H, then in right here you could write H. Alright, so the probability that we pull a heart. Alright, so keep in mind there are 52 cards total in the deck, so that'll always be your denominator when you're choosing a single card. There are 52 outcomes in the sample space. Now, out of those 52 outcomes, how many of them satisfy being a heart? Well, all of these have hearts on them, so how many cards is that? Alright, so there'll be 13 cards that have a heart. So it'll be 13 out of 52, or 1/4 of the deck. What's the probability that the card is not a heart? Well, we could do 1 minus the probability it was a heart. So 1 minus 1/4 is 3/4. That's just one approach to computing this probability. What's the probability that when you pull a card, you have a king or a 2? Now again, I don't want two different probabilities here. What this notation is saying is that if the card is a king, you want to count it, or if the card is a 2, you want to count it. Either one of those types of cards would be considered a successful outcome. Okay, so there are 52 cards total in the deck. Okay, so that builds our denominator. Now, how many of those cards satisfy either being a king or satisfy being a 2? Well, the kings are over here, so there are 4 cards that satisfy being a king. And the 2s are over here, there are 4 cards that satisfy being a 2. So how many cards are a king or a 2? There'll be 8 cards total. So there'll be 8 cards that satisfy being a king or a 2 out of the 52 cards in the deck, and then that simplifies to 2 out of 13. What's the probability of getting a face card? So as a reminder, face card means it's either a jack or a queen or a king. Alright, so there are 4 jacks, there are 4 queens, there are 4 kings, so overall there are 12 cards that are considered face cards out of the 52 cards total. So then that builds our probability, 12 out of 52, which simplified then would be 3/13. The next probability. What's the probability that the card that is pulled from the deck is a heart and a diamond? Okay, so keep in mind, you're only pulling 1 card at this point. So out of the 52 cards in the deck, how many of them satisfy being a heart and being a diamond? Okay, well, here are your hearts right here. Alright, so in this set of hearts, how many of those hearts are also diamonds? Well, none of them, right? I mean, that's a totally separate category. The diamonds are down here. So for a card to be both a heart and a diamond, there are 0 cards that satisfy that. So then that probability is 0. A card cannot be both a heart and a diamond. Now in this last one, what's the probability that you have a red card and an ace? Okay, so again, it uses the word "and" here. So contrast that with the "or." With the "or," as long as you satisfy one or the other, you got counted. Now, if you satisfied both, I guess you're just doubly blessed, but we don't care about that. We just have to satisfy one or the other in order to be counted in my event. When the word and is here, you have to satisfy both of these criteria. If you don't have anybody that satisfies both of them, well, then your count is 0. On this case, though, the cards that are red and also an ace. Okay, so let's take a look at our deck of cards. Here are the red cards down here. Okay, so that satisfies the criteria of red. Now, it says and ace. So out of my red cards, how many of them are also aces? These two right here. Okay, so my count then for being a red card and being an ace, there are 2 cards that satisfy it out of the 52 cards total, which would simplify to 1 out of 13. Okay, so what's going on here is a card cannot be both a heart and a diamond. Okay, so that's why this count was 0. Okay, but this count is 2 because you have your red aces. Okay, you have your ace of hearts and you have your ace of diamonds. Okay, so those satisfy both being a red card and being an ace. So that's where the 2 comes from out of your 52 cards total. Alright, so that wraps up our examples in section 11.1. So just as a recap, we talked about some of the vocab about what a sample space was, what an outcome was, and then how outcomes can get pooled together in what's called an event. We looked at examples involving looking at rolling a die, playing cards, and also just looking at pulling, like for instance, numbers out of a hat. Our first examples involved empirical probability, which looked at the outcomes of an experiment or the results of an experiment in order to build your numerator and denominator. So in an empirical probability, the denominator is the number of trials. The numerator is how many of those trials satisfy the event that you're keeping track of. Then we looked at theoretical probability. So in theoretical probability, the denominator is how many outcomes were in your sample space. Okay, so no experiment was run at that point. In a theoretical probability, we just look at the denominator being how many outcomes are in your sample space, and then the numerator then is out of those outcomes in your sample space, how many of them satisfy the event that you're looking at. Now, the law of large numbers ties the 2 probabilities together. What the law of large numbers says is as you perform an experiment over and over again, the empirical probability should approach the theoretical probability.